This video will describe the relationship of the radius of the alleged ball Earth to the flat Earth. So we are told that the radius of the ball Earth is 3,958.8 miles. So the distance from the core to the surface is 3,958.8 miles. When one researches the history of the meter, one learns the meter was originally defined in 1793 as 1/10 millionth of the distance from the equator to the North Pole. And you also notice it was redefined in 1799 in terms of a prototype meter bar. They claimed they were measuring 1/4 of the circumference of the ball Earth. In actuality, they were measuring 1/2 of the radius of the flat Earth. So they measured from the North Pole to the equator, which is half the radius of the flat Earth, and they claimed it was 1/4 of the circumference of the ball Earth, and then they solved for the R radius. So in order to determine how in order for them to determine this number, they used circumference equals 2 pi r, so that's 1/4 of the circumference. They started with the 10 million meters, which is 10,000 kilometers, converted to miles is 6,213.7 miles. Multiplied that by 4, since that was 1/4, in order to get the circumference of 24,854 miles. Now they had C equals 2 pi r, so they just divided by 2 pi in order to derive R, which was 3,955.8 miles. And as you can see, they now use 3,958.8 miles, so maybe they mismeasured, I don't know. But if one were to use 3,958.8 miles, then multiply by 2 pi to get the circumference, and then you divide by 4, and you get the the distance from the North Pole to the equator of 6,218.5 miles. So I believe that the distance, I'm going to show 4 pieces of evidence that shows that the distance from the North Pole to the equator is 6,218.5 miles. So half the radius of the flat Earth is 6,218.5 miles. If one were to double it, you then get the radius, but that's tricky because we don't know if there's land beyond the ice wall and all that. But as long as you can verify this number here, then you can use this to make other calculations. So the 4 pieces of evidence of the distance from the North Pole to the equator: one, you do a Google search, that was previously done, and obviously it says this is the definition. This is because the definition of a meter is 1/10 millionth of the distance from the North Pole to the equator. So they're showing you the distance right here. And again, 10 million meters gives you 6,213 miles, and I guess they made an adjustment and now it's 6,218.5 miles. Second piece of evidence is a Google Earth measurement. Obviously the North Pole is located at 90 degrees north. I was able to get 89.69 degrees north, took that down to the equator, and got 6,210 miles. And again, that is pretty close to the 6,218 miles. Third piece of evidence is the United States segments on a Gleason's map. So in my video, Flat Earth, Width of the United States versus Australia explanation, I demonstrated that the east-west USA, or all land masses, have a east-west distortion. So the width of the United States is 2,811 miles. There was about a 10% distortion, resulting in a distorted width of 3,092 miles. Again, North Pole to the equator, 6,218 miles. So you should be able to fit about 2 United States in this space, in this distance from the North Pole to the equator. And I tried to do that, and I was successful. So 1, 2. And then if one were to use the height of 1,584 miles of the United States, where the northernmost part of the U.S. is North Dakota, southernmost part of the continental U.S. is Florida, then one should be able to fit about 4 United States from north to south in this space from the North Pole to the equator. And I was able to do that. So the fourth and worst piece of evidence are flight paths. They're not a good indicator because there are no commercial flights that I could find from the North Pole to the equator. Second, it's difficult to determine how fast the plane is moving. It depends on how much time is spent reaching and in and out of cruising altitude, and sometimes the flight maybe veer off. It won't fly in a straight path. Maybe it has to get into the jet stream, which requires it to go off a straight line. And it also depends on how fast the airplane is moving while at cruising altitude, which depends on maybe the speed of the jet stream. And third, it's difficult to find flight paths that fly directly north and south, since most airports do not line up in such a way. So the 30 closest airports to the North Pole: Alert, Eureka, and Longyear. Alert Airport is operated by the Canadian Department of National Defense, so I was unable to get any information on that. Eureka is operated by the Environment Canada, not able to get any information on that, so I used the Longyear Airport at Svalbard in Norway, which is a national airport. Its location is 78 degrees north, flying to Oslo, Norway at 60 degrees north. So I got the distance and duration of the flight of 1,251 miles and 2 hours 55 minutes. I then took the distance from the North Pole to the equator in miles, which was 6,218.5, divided by 90 degrees. This distance equals 90 degrees, so it results in 69.1 miles per degree. I then calculated the flight path in degrees and converted that to miles. And so 6218.5 is the distance from the North Pole to the equator, divided by 90 degrees. It gives you miles 2 degrees. And the conversion results in 1,274 miles compared to the 1,251 miles. And then the second example, the flight path from Edmonton International Airport at 53 degrees north to Los Cabos, Mexico, 23 degrees north, and it is a 6-hour, 15-minute flight duration, and the distance is 2,105 miles, 106 miles, and I did the same thing, and I came up with 2,091.2 miles. So it looks like the distance from the North Pole to the equator, or half the radius of the flat Earth, is 6,218.5 miles, and this number can be used to make other calculations about the flat Earth.